does that mean I can appear the quiz too, and then later if I got through, I'll be eligible to write the enter?
Yes, that's as far as I know, that in any one of the quizzes, if you pass, you'll be eligible, but it will be better if you check the grading document once for CT.
Oh, thank you, ma'am. Okay.
Yeah. Okay, is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
See, so last week we did week one, right? Week one was about mostly we did flowcharts, how the program flow occurs, that type of things we discussed. Now, like I said in CT, we will be dealing with pseudocodes, right, throughout the course. So week two is the beginning of where we start writing pseudocode. Pseudocode is what? Nothing but a representation of an algorithm in plain English. Right. So step by step we will write what we will do in each step. So just the basic flowchart that you saw, we'll just give it a more structured representation. So the first thing we will learn is again, let's check out the flowchart for how to find the maximum maths marks. Then we'll come to the pseudocode from there. Okay. So this was iteration with filtering, right? What was filtering? Anyone remembers what is filtering? Filtering means what? That we are putting some condition, right? Like if I said that I want maximum maths marks out of
Filtering
all
out the
boys,
data that we needed.
right? So we are just putting a condition. Like here, like I said, that if I want maximum marks of all boys, so here this all boys, this condition, this is one filter. So you can do multiple filters in one program also, that is also possible. Right. So this flowchart it says, so first is your terminal box. I hope you remember all the boxes, right? We start with a terminal. Then these are processor activity box. These are decision boxes, right? And these arrows are just representing the flow. So first we have the start box. Then we initialize whatever variables we need. Then you check in the decision box that are there more cards in your pile one or not. If pile one is empty, then we'll just go here and end the program. If there are more cards present, then you pick up the first card. You come here to this process box, right? 1 second. Or please mute yourself.
कसलाई दुईटा बनाएको किन ए ए बुझेँ मैले
Okay. So after you pick the first card, then you come to this process box. Then you read that card and you move to pile 2. Right. And then we have to check for the condition here in this another decision box. So this could be the filter, like whether the gender of that person is male or not. That could be in this filter box. If it is yes, if the answer is yes to the condition, then you do something in this process box. If it is no, then you do something else here. And then in both cases, we'll again go back to this first decision box where you'll check for more cards in the pile. This will continue until this pile 1 becomes empty. That is, there are no more cards present. Right? This is the basic structure of the flowchart. Now, it is saying iteration with filtering, modify for max. So now we'll have one variable called max. Let's say we are trying to find the maximum marks. So we have to store that mark somewhere, right? So that marks will be stored in your max variable. So after I start the flowchart, then in the first process box, I have to initialize whatever variables I'll be using in the flowchart. Right. So since I'm trying to find max, so I will store that max value in this variable max. So I'll initialize max to 0. Max equals 0. What is this operator known as?
Assignment operator.
Assignment. Right. So you assign 0 value to max. Now, again the same thing. So check for more cards. If there are more cards present, pick a card, read it, move file to, and then check for the filter and continue like this. So let's go to the actual program, right? This one. See, first start, then we initialized max to 0. Then you're checking, are there more cards in pile 1? So obviously, if it is the first iteration, there are going to be more cards. Like I said, in sports data set, we had around 30 cards, right? So you pick up the first card, read it, move it to pile 2, then check whether the mathematics marks of that person in that card is greater than whatever value is stored in max right now. So max currently has the value 0. Let's say the card that I picked of this person X, this person has, let's say, scored 50 in math. So 50 is greater than 0, right? That means it will go to this yes branch. 50 greater than 0. So you come here and you assign that new value 50 to max. That is till now, whatever cards we've seen, this is the maximum value we have got for max. Right? So now max contains 50 at this point. Now let's say I again go back here. I pick up the next card, read that card, move it to pile 2. Now you have to again check this condition. Let's say this person has scored 65 in math. So now when I do this comparison, this will be between 65 and 50. Current value of max is 50 and current value in card is 65, maths marks. So 65 is greater than 50. That means we'll again come to the yes branch, again modify the value of max. So now max becomes what? 65. Right. So like this, I'll continue the iterations. Let's say in third iteration, I pick up a card where the person has scored 45 in math. So now what will happen in this decision box? Current max value is what? 65. And current card's math mark is what? 45. So is 45 greater than 65?
No.
So I'll go to the no branch. That means max will not be updated. I'll just go over and pick up the next card. So max is only getting updated when I find a greater value than the current max value, right? So like this, if I continue, at the end of the execution, when I have gone through all the cards in my pile, max should contain what? The maximum mathematics marks. Correct. Anyone has any difficulty understanding this much?
No, ma'am.
Okay. So this is the flowchart to find your maximum marks for a particular subject. Now, this is the same thing. So now it is saying that we want a flowchart where we find the maximum marks as well as we keep track of the card which has the max marks. So how do we keep track of a card? A card has a unique identification by its sequence number, right? That is unique for every card. So I want that sequence number also, that which card is having this maximum marks, right? So now we have two things to keep track of. One is the max mark and one is the card that holds the max mark. So earlier this was the flowchart, right, that we just did. Now what modifications can I make? Now since I need a card ID to store, right, I need to store the card ID where the max mark is present. So I will need another variable where I will store this ID or sequence number. So let's initialize one more variable called max card ID. But it is saying that initialize it to -1. Now why am I not initializing it to 0?
0 is included in the sequence number.
Right, because there is already a card which has the sequence number 0, so I cannot start with that. That represents a card, right? So I have to start with some value which is not belonging to any card. So sequence number starts from 0, so I'm starting this from -1, initializing it to -1, right? A neutral value. So
Madam, sorry to interrupt. So I don't understand, madam. Why we are keeping -1? So can you explain?
So we want to keep track of the sequence number of the card, right, which stores the maximum mark.
Okay.
So we have to take a variable, separate variable where we'll store that sequence number. So I took this variable max card ID. Now we have to initialize the variable with some value, right, in the beginning. So I cannot
Okay.
take 0 in this case. Why? Because 0 is already a sequence number of some card. Okay. So it can be that the max value is stored in the card with 0 sequence number. So I cannot assume that. I have to start initializing with some number or some value which is neutral, which is not a sequence number of any card. So since -1 is one such value. Okay. Now, if I start with 0, okay, if I give this max card ID to 0, that will be an actual sequence number I am initializing it with. Okay, that represents a certain card. But I cannot have that. I need to only update this variable when I have visited a card and read the sequence number from that card. So initially I haven't visited any cards, right? So I need a neutral value. That's why I'm taking -1. If the sequence numbers had started from 1, then I can take 0. Okay. So see, first I have now start. Then in the next process box, I have two variables now. One is max, which is assigned 0. Another is max card ID, which is assigned -1. So now I'll check in my pile that are there more cards. If yes, then you pick the card, you move it to pile 2. Then again you check this same condition that whether the max marks is less than the current mathematics marks or not. So if max is less, then you update max, otherwise no. But now one more thing has to be updated, that is this max card ID. Right. So we need to add that to this process box. So in this same process box where we were updating max, we will now also update max card ID. So every time we find such a card, okay, whose max marks is greater than the current value of max variable. In that case, max will be updated, right? And along with that, max card ID will also be updated. Let's say the first card that I pick is a person who has scored 50 in math. And let's say the sequence number of the card is 23. This is ID. Okay, and this is marks. So if this is the case, then initially max is 0, max card ID is -1, right? So this decision box here, a card x dot max is 50. Is 50 greater than max? Yes, max is currently 0. So update max to what? Max will now contain
50.
50.
Yeah.
And max card ID will now contain what? 23. The corresponding sequence number of this card.
Yeah.
Now again, I'll pick the second card. Let's say this person has scored 45 in math and 15. Okay. So in this case, again, value greater than max.
No.
Is 45 greater than 50? No.
No.
That means no update will happen. Not in this max variable, not in this max card ID. Max card ID is only updated when max is updated, right? So nothing will change. Now the third card that I pick, let's say the person has scored 60 and his ID is 33. So now 60 is greater than 50. So max will now be updated to 60.
60. Yeah.
And max card ID will now be updated to
33.
So like this, I will go on till I reach the end of the pile. At that point, max will contain the maximum mathematics marks and max card ID will contain the sequence number of that particular card, which contains the maximum mark. So like this, you can place any filters that you want, right? Is this clear?
Yes, ma'am.
Others, anyone else? Okay. So here we did two things. First, we found out what is the maximum marks, then we also kept track of the card, right? Now, what is the problem they're saying is, what if there are more than one cards with the same mark, right? So it is possible that two people scored the maximum mark.
Yes.
Right. So if two people scored 100 in math,
Yes.
in that case, I need to store both of those card IDs, right?
Mm.
So that is not happening here. Only the first one is retained. Why am I saying the first one? Because let's say the first person that has scored 100. So for them, the max was updated to 100, and let's say the card ID was just take 10, any random card ID. So after this, I also picked another card who has also got 100 marks. But is 100 greater than 100? No. So this condition will be false, even though that is also the maximum mark. So this is one problem with this approach. Now, what can we do? We can keep a list of IDs, right? That means we can make max card ID into such a data structure or such a container which can store more than one value. right? That is max card ID now not only stores one card ID, it can store multiple card IDs. Also, one more condition that we need to change is, can you tell which one? Just look closely. So I want all the people who have scored the maximum mark. That means this condition needs to be changed. It should be greater than equals to, right? So that if one person scores 100, max is updated to 100. Now next person, if he has also scored 100, which is the maximum mark, but if I don't add an equals to sign here, then this condition will be false because 100 is not greater than 100, but 100 is greater than equal to 100, right? In that case, I can again come here to the yes branch and store that card ID also. So two things need to be changed. One is this greater than equal to sign has to be there so that I can account for more than one maximum. And one is that this max card ID should be storing all those card IDs that have the maximum mark. Okay. So let's see how they're implementing that. See. Up to this, everything is same. Okay. You have two variables, max and max card ID. Max card ID has a -1 stored in it like this. So after this, so you check this condition. If the max marks of the card is greater than max, then it is yes, and you come here and you update, just like we were doing. But if it is not greater than max, let's say current max value is 100. Max is currently storing 100. And the max card ID is storing, let's say 10. So the 10th card, that is the card with sequence number 10, has the maximum value of max 100. Now let's say I pick up another card whose sequence number is 20 and they have also scored 100. So in that case, this decision box condition will be what? Is 100 greater than 100? No. So you go to this branch. Then you check, is 100 equal to 100? Yes. Right. So in that case, what will you do? Here in this process box, something will happen.
Hello, ma'am.
Yeah.
Sorry to interrupt you, ma'am, but I have very small doubt in some questions in practice assignment week 2.
Yeah, practice I will discuss after the theory part. Okay.
Okay, so I have also in doubt in activity questions 1 to 3 questions. Can you please solve?
Okay, look, first I'll complete the theory, then I will discuss activity practice questions. If there is time, we will take up the activity ones or activity questions will be discussed in tomorrow's session. Okay.
Okay, so I have also doubt in week 1 in practice assignment 11 questions.
Yeah. Okay. Week 1 doubt I'll take.
Number 11.
Sure. Okay. You wait till the end. After this theory, I'll take up all the questions. Okay.
Okay, ma'am. Thank you.
Okay. So if this card is equal to max marks, whatever max is storing. So both people have scored 100, right? So current max is also 100 and current card value is also 100. So 100 equals to 100. That means we will append the card ID to max card ID. So max card ID already contained that first card's ID that was 10 who had scored 100. Now this person with card ID 20 has also scored 100. So max card ID will contain both of these ID values. Okay. So since now we haven't learned what a list is, but a list is one such data structure that can store more than one value. So we'll make this into such a list, which will store all the card IDs of the people who have scored the maximum marks in a certain subject. Okay, so this is how we can modify the flowchart for that. Just a second. Yeah. So append of A and B is AB. Okay. That means basically all of the ID numbers like 10, 20, if there is some other ID 40 who has also scored 100, that will also be stored in this same max card ID. Okay. So max card ID contains the list of all the card indices with the max marks. And max variable itself contains only the maximum marks because maximum mark can only be one, right? It cannot be more than 100. Or if the maximum marks is 99, then it is 99 only. So the max value is only a singular value, but a number of people can score that same value. So we need all the card IDs for all those people who have scored that max value. Okay, so max variable contains max value and max card ID contains all such card IDs who have scored that value. Is this flowchart clear? Anyone, any doubt?
No, ma'am.
No, ma'am.
So let's go to the next slide. Okay, now we'll come to pseudocode. Okay, so this is again a flowchart. So start, count, count is a variable. So this is the first flowchart. Remember where we were counting number of cards, right? So count is a variable which is set to 0. Now we are checking that are there more cards in pile 1? If yes, then you pick a card, you move it to pile 2 and increment count like this until you reach the end of the pile of cards. So at that point, count should have the value of the number of cards that are present in pile 1. Right, this is very simple. Now, how can we change this to? So this is basically just a representation of like the flowchart and what it represents that is written here. So we know 3 types of nodes are there: process box, terminal, decision box. Arrows indicate operation flow. All this we know. Now, what is the advantage of a flowchart is that it is a visual representation. It is much easier to understand. Just looking at a flowchart, you can just tell what's happening, right? It's a very easy representation. But there are cons of that also. What are some disadvantages is that now this is a very simple procedure, but in day-to-day life, the programs that we write, the procedures that we need, they're not so simple, right? They're much, much more complex than this. And even if the complexity increases a little bit, that can affect the flowchart a lot. That means just a little bit of increased complexity can give rise to a much larger flowchart. So it is a very time consuming thing to draw that. Because see, if you are drawing a flowchart and if there are a lot of conditions in it, you need a lot of decision boxes. And every decision box has 2 branches. So it can branch out very fast and it can become very big and uncontrolled in a very small amount of time. So that is one disadvantage of flowchart. So flowchart is used basically for people who are just beginners in programming, right? Who are just starting to learn. So for them, this is a nice visual representation. It's easy to get, but it can also become very difficult to manage once the processes get more complicated. Okay, so these are, then again, you cannot collaborate with more, like if more than one person is working on the same flowchart, it can be hard to keep track of what is the latest version. That is also one difficulty. Now we will come from this pictorial representation to a textual representation. And this is your pseudocode, right? So this simple program that we saw in flowchart, that is counting number of cards. If I write this in pseudocode format, then this is how it will look like. So step 0 is the start, right? This terminal start, that is your step 0. Then step 1 is initialize count to 0. So whenever I write this in bold, it means this is a variable. Okay. So count is a variable which is initialized to 0. Now check cards in pile 1. This step 2. That is just relate with the diagram. Okay. This is this step. This is this step. Check cards in pile 1 is this decision box. If no more cards, go to step 8. That is end. That means this control flow. But if there are cards, okay. So then pick a card X from pile 1. That is this step. Now read it and move it to pile 2. That is this step. Now increment count this step and go back to step 2. That means this iteration. So this will again go back to step 2 where we will check the cards in pile 1 if there are more cards or not. So this is how you can represent in the form of pseudocode from a flowchart, right? So just you can relate all the steps to the diagram. Now let's try a little bit more complicated ones. So this is one conditional execution. First of all, let's learn this. So what is conditional execution? Like step 3 and step 4. So in step 3, we are checking if no more cards, go to step 8. So this if means there is a condition. That means if file is empty, then go to step 8. That is end execution of program. And step 4 it says that pick a card X from pile 1. That means this is else part, that if no more cards, then go to step 8. But if there are cards, then you pick one card, right? So these two steps are based on condition. So this is conditional execution. Repeated execution is the steps which are repeated again and again, right? That is the steps which come under the iteration. So step 2 to 7 is repeated. So step 2 was what? Check cards in pile 1. So basically this entire loop, basically, this part. This is all inside an iteration, right? So this is your repeated part. So this is repeated execution. This will go on again and again till the condition here becomes true. That is, there are no more cards in pile 1. So that's conditional and repeated. Now, so this is how you write it. Okay. So we won't write all those step 0, step 1, step 2. We will just start with the actual code. So initially count is a variable that is assigned 0. Then this condition that we have, right? We are putting this inside a while loop. So this is a while loop. So this part of inside the while loop, this will execute until this condition becomes false. That is, pile 1 has no more cards. So this part will be repeating until this condition becomes false. So while pile 1 has more cards, you pick a card, move it to pile 2, increment count. So this will continue till pile 1 is empty. Okay, so this is a while loop. While loop. Okay, up to this, I think everything should be clear. So we assigned a value to a variable. We repeated the steps until the condition holds. This is the condition. Pile 1 has more cards. Then you mark the start and end of a repeated block. Okay, so for that we have these curly braces. So this, whatever part is inside the curly braces, they are the repeated block. This code will run again and again till this condition becomes false. So summary is that flowcharts are easy to read, visual descriptions, right? But they can become very hard to manage once the procedures become more complex. So that's when pseudocode comes in. So we can just write down the steps in a textual format. It is much more structural. It is much more easier to edit or collaborate on, right? So there are two types of execution we saw. One is conditional, one is repeated. Conditional is when there is an if statement that is checking some condition that if there are more cards in the pile, then do this, otherwise do this. This is conditional execution. Repeated is that when some steps are being repeated again and again when a condition is true. Like we saw that while pile 1 is not empty, so you keep on executing that part of the code that is written between the curly braces. Curly braces are there to show you where the repeated block starts and ends. Okay, so this is the basic summary that we learned till now. Any doubt up to here?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
So let's do this last. This is the last slide. Then we'll go to questions. Okay. Okay. So this is again the same counting cards. I'm not going through this again. We just did this. Okay, let's take a different one. So sum of maths marks. Okay. So we have seen already how to find sum of maths marks in form of flowchart, right? So we had a sum variable which we assigned the value 0. This is the flowchart. So you started assign the value 0 to a sum variable. This is supposed to store your sum of maths marks. Then again, you repeat all these steps that if there are more cards in pile 1, then you pick a card, read it, add its maths marks to sum. Then again, keep on doing this until this pile 1 becomes empty, right? Now we have to write this in the form of a pseudocode. But remember, when we write pseudocode, actually, then you do not need to write the start and end. Okay, this is for flowchart only. So in pseudocode, we don't write start end. It's just for you to understand. So we'll directly start with assigning values to variables. Okay, that is initializing variables. See, first sum is initialized to 0. Then we are checking while pile 1 has more cards. Okay, so this is the start of the while loop. Everything that is inside the braces is what? This is the block of repeated code. So this code will run again and again till this condition becomes false. This pile 1 becomes empty.
Madam, then the pseudocode, how it will know the beginning and end actually?
See, pseudocode actually is something that doesn't run, or we don't compile it or anything. Okay, it's not actual code. It's just a
Okay.
representation of a program. So it does
Okay,
not.
this is for understanding. So directly we
Yeah,
can
yeah,
tell the. Okay,
correct.
understood.
So like in other programming languages, in C you have these header files, some return statement. These things are there, right? So
Yeah.
since this is just pseudocode, it will not run or compile or anything. So there is no need for start or end.
Okay.
So next, inside this curly braces, you will do the same thing, pick up a card, read it, move it to pile 2, add the max marks to sum. Okay. So there is a better way of writing it. So now instead of writing add max marks to sum, we will write sum equals to sum plus x dot max. This representation we did last day, right? That is, sum is, first of all, sum is 0. Let's say the first person has scored 50. So sum is equal to 0 plus 50, that is 50. Next person has scored 60. So sum is equal to sum plus x dot max, that is 50 plus 60, that is 110. Like this, you keep on updating sum till there are no more cards in pile 1. Okay. This is not mathematical equality. This is assignment. Equality is this, exactly equal to, two equal to's. So sum on the right is the current value. Okay. Whenever we write this type of notation, so the sum on the right, that is this one, is the current value of sum. And the left one is the updated value. That is the first, let's say first person whose card we picked has scored 50 in math. So initially sum's value is what? 0. So when I said sum equals to sum plus x dot max, so this sum means 0. And the current value in the card is 50. So 0 plus 50 is 50. This is stored in this left hand side sum. Next person has, let's say, scored 60. Okay. Now when I update this, now this sum is 50. This x dot max is 60. This total is 110.
Yeah.
Okay. Like this you will do. Okay. So the right hand side sum is the current value of sum, and left hand side is the updated value. So in flowchart also, process box, we'll write like this: sum equals to sum plus x dot max. Okay, count also we can keep track. Here count is not required.
Then the equal
But
sign.
whenever we use
Sorry. Then the
equal sign means we are assigning the value. Okay.
So assigning the
Whatever is
value,
sum,
double equal sign is equal to, which means
comparison, yes. You are checking
so
whether two values are exactly equal or not.
okay, understood.
Yeah. Okay, so sum of max marks is, I think this is done. So now let's take another one, that is sum of boys max marks. So now we just put one more filter where we check that whether X is a boy or not. Right. So we can just place that condition inside our pseudocode also. Before you do the sum, you just check. See, while pile 1 has more cards, so you first initialize sum to 0. Then while pile 1 has more cards, you pick a card, you read it. Now you check if X is a boy. So this is an if block, if statement, conditional statement. Okay, whatever is inside these curly braces will only execute when this statement is true. That is, X is a boy. So if X is a boy, then sum equals to sum plus x dot max. So only those cards where X gender is boy or male, then only we will update some variable's value and add the max marks to it. If it is a girl, we won't execute this statement. Okay, so this statement inside the curly braces of an if will only execute when this condition is true, when the if condition is true. Okay, so this filter can be implemented in this way in pseudocode using an if statement. Okay, so this is conditional execution again. So actually this is how you will write. So if x dot gender equals to m. So this is your equality or conditional comparison operator. Okay. See, this is checking whether the card gender, whatever is stored in the gender attribute of card X, is exactly equal to M or not. M means male here. Okay. If it is exactly equal to M, then we will add the max marks of that person to some variable. Otherwise, not. Okay. So this is conditional execution again.
What is use of assignment sign?
Assigning some value to a variable, like this sum that you did. So you have to assign this updated value to some variable, right? That's why you're using this assignment here. Whenever you assign any value to a variable, we use assignment. Okay.
Okay.
Okay. Now we can do one more filtering, that is sum of boys and girls marks. So we want both. So let me find the actual one. Yeah, this is okay. So now we want both boys maths marks and girls maths marks. Both sum we want. So we now have two variables, boys sum and girls sum. Both are initially 0. Now while pile 1 has more cards, pick a card. Move X to pile 2 after reading it. Now you check the gender. Is it male? If it is male, then you add the marks to boys sum. Else, that means if this condition is false, it is not male, then we will add the maths marks to girls sum. Okay, if condition is true, add to boys sum. If condition is false, add to girls sum. So you can do the other way around also. Here you can check if X dot gender is equal to F. Then these two statements will switch places, right? If you're checking for female, then if this is true, then you add it to girl sum. If it is false, then you add to boy sum. You can do either way. Okay. Okay. So this is again the maximum maths. I think here some problems are there in the slides actually. So they are saying maximum marks here, but they're still finding the sum of math for gender male. Yeah.
Ma'am, can we get this presentation?
These are all present in your supplementary contents, okay, in the portal. Okay. So this one is saying finding the maximum max. So finding maximum max means we need a variable maxim, right, which we will assign 0 initially. Let's go to the entire code, not like this. Yeah, this one. So we want maximum max marks. So we will store that in maxim variable. So maxim is initially assigned 0. Maximum among everyone. Okay, no gender specification, nothing. So only one thing that we have to find maximum marks, no filters. So while pile 1 has more cards, pick a card, read it, move it to pile 2, check if that card's max marks is greater than whatever is stored in maxim or not. Let's say first person scored 50 in math. Is 50 greater because initially maxim is 0. Is 50 greater than 0? Yes. So you update maxim to 50. Next person has scored 60. Now maxim is what? 50. It is containing 50. So pick a card, move it to pile 2. Now, how much has that person scored? 60. Is 60 greater than 50? Yes. So again, update maxim to 60. Now the third card that I picked, let's say the person has scored 55. So x dot max is 55, but current maxim is what? 60. Is 55 greater than maxim? No. So no update. So this will only update when the current card's max marks is greater than the current value in maxim. Okay. So like this we can do at the end of execution, maxim will store your maximum max marks value. So see how much easier or how much shorter it is to write in pseudocode instead of, right? Okay, one more example we can take. Yeah, this one. So finding the card with maximum max marks. Like we did now, we just want to store the sequence number of the card. So I already did this in the flowchart format. So here also same thing, we need two variables, one to store the maximum marks, one to store the sequence number. So maxim is initialized to 0, max card, that is sequence number storage variable, that is initialized to -1. Right now, again, you check the while loop condition. Pile 1 has more cards or not. If yes, pick a card, read it, move it to pile 2. Come to the if statement, check whether the max marks is greater than the maximum, current maximum or not. If it is, then you update both the variables. So you update the maximum marks as well as the max card variable, you put the card ID or sequence number in. Okay, but what is the problem here? Yeah.
Madam, okay, madam, see here, same earlier question only because I got more doubts in my mind. See, if I assume same is 0 here also, max card also 0 means what will happen actually?
So if I assume here 0, see, this is just a convention, okay, that we don't assume such values which might appear in the act data.
It is
Okay,
only the
so
numeric
max
only.
card,
It's the assignment, right? So max MSC we are starting initially with 0.
yeah.
Same
See,
way
if you
we can
do this, if
initialize.
you initialize it with 0 also, okay, you're asking what will be the problem, right?
So we can initialize it. See, what is the purpose we are taking -1? That's only I'm thinking. We can initially with 0 also, right?
See, if you initialize with 0, okay, now let's say that uh, this max card currently is just storing one value, right? Only one value it is storing of the person who has scored the maximum marks. We are not taking into consideration the fact that there can be more than one such person who have
Okay.
scored the max marks. So
Okay.
even if I take it 0 right now, okay, let's say
Okay.
max card is 0. Now the
Okay.
first person who has taken, who has scored the this thing maximum marks, let's say the first person has scored 19 marks and their sequence number is 1. Okay.
Okay.
So x dot max is 90, that is greater than maxim, fine. I'm updating maxim to 90. And
90.
max
Yes.
card is now containing 1. Okay.
Yes.
So next card that I pick up. So like
Mm.
this, I can do this till I find the maximum marks. This will not affect anything. Okay, even if I started with 0. But this is not recommended because this is a very simple program. See, here it is not affecting anything. But there might be programs where if you take that value, it might hinder the process in such a way that if we take such a value which is going to appear in the data set itself, okay, some comparison operators might be there which will not let certain cards even enter the comparison because of this value. Okay, we will have some certain such examples. I think on the along the way we'll have certain examples, but in this particular one, there will not be a problem even if you take it as 0. But it is not recommended because 0 is a particular sequence number. So we want to initialize a card or a variable. I'm sorry, we always want to initialize a variable with such a value which is neutral. Okay.
Okay. If
So
if we introduce one more variant, for example, one more variant, whatever it is, okay. So then what we'll assign? We'll assign -2 or what we'll do?
one more variable to store what? What is the purpose of the variable?
Maybe okay. Your card number. Then another one is they passed in two subject. So
Yeah, sure. See, it depends on what you're trying to accomplish. If I'm trying to get a count, okay, then I will initialize it with 0. That I haven't seen any cards till now, so it is initially the value is 0. If I want to find maximum marks, they started with 0.
no, madam. My
Now you tell
question
me
is
one thing. If
now
yeah,
here one variable we are assigning 0, and if you are
hmm.
introducing second variable, so we are using -1. If you introduce another one more variable, if you
No,
want to
no, there is
find
no such thing that if we are introducing one more variable, we can assign it a certain value. No, it
okay.
depends on what is the purpose of that variable. Okay.
Mm,
Now, if I want to also store the minimum marks in math, okay, let's say I have a variable called min m. This is supposed to store minimum math marks. Correct. So if I initialize it with 0, then will this work? Because then my condition is going to be what? I have to check if x dot math is less than min m, only then min m will be updated with the x dot math value. But if I initialize it with 0, then can there possibly be a value that a student has scored that is less than 0? No, student can score between 0 and 100,
yes.
right? So in that case, what we do is, in such a case, if we want minimum, so we will assign min m such a value which is much larger. Okay. Which is larger than the largest value that a person can score. That is 101 I can assign.
Mm-hmm.
So there will be some person whose card comes first. If that person has scored even 100. Okay. So 100 is less than 101. So currently minimum is 100. Next card I pick up, some person has scored 50. So 50 is less than 100. So assign it. Minimum becomes 50. Like this. So it totally depends on the initialization will depend on what is the purpose of the variable.
Okay.
Okay.
Okay. Okay.
This will become clearer while we do more problems. Okay.
Okay.
Okay. So now we are trying to keep this track of the card sequence number like I did. So you just check the same condition. If the marks is greater than current max, you update max and you also store the card ID in max card. Okay. Now we saw one problem was there that if there are multiple such people who have scored the same max mark, in that you have to make this max card into a list of such IDs. Right. So max card will contain a list of all those IDs who have scored the maximum marks. But here we are not showing you that since we haven't discussed list concept yet. That will come in week 5. Okay. So the summary of this is we saw assignment statement, that is your equal single equals. This can be used to assign any value to a variable. Okay, we saw this type of assignment, sum equals to sum plus x dot max. Here this sum is the present value of sum, and this is the future value, right? Updated. The value that will be there after I perform this addition. Then we saw conditional execution, right? That if statement, or even that decision box where we saw that while if there are more cards, then you go to this. If there are no more cards, then you end the program. These are all conditional execution, where there is a condition in play, right? An if statement is there. So one more thing we saw is repeated execution. So whatever comes under the while condition, while loop. So whatever comes inside those curly braces, those statements are repeated again and again. So that is repeated execution. Now this is very, very important. Please don't mess this up in exam. Equality means double equals. Assignment means single equals. Okay, whenever we ask you that to compare two values, to compare the equality of two values, so you will use this one, double equals. Okay, so this is your mainly theory for week 2. Now let's take some. First, you tell me if anyone has any questions from week 1, practice graded anything. Are there any doubts in week 2, whatever we discussed? Anyone?
No, ma'am, please start.
Okay, you tell me the question number of whatever doubts you have from week 1, practice graded assignment. Anyone has any doubt?
Yes,
Week
ma'am,
1, I'm asking.
I have doubt in practice assignment 1 in 11 questions. Sorry, 11 number question.
Is it the flowchart question?
Yes, ma'am.
That one I discussed in last week's class also. So I'd suggest that you go and check out that one. It's at the end of the lecture. You'll find the recording. Okay, let's discuss questions that
Okay.
haven't been discussed yet. So
Okay,
I'll still tell you that in that type of in an example value, right? A, B, C, three variables are there. Like A, 2, B, 3, C, 4, and then check. Or you can take A, 5, 6, 7, like this. Any value you can take. Just make sure the condition is followed that no two values should be same. Then you will find out the answer. Okay, just go through the flowchart with those values. Okay, next, which question?
I have doubt in activity questions in week 2.
Okay, week 1
Activity
graded. Does
2.1
anyone have
question
any
number 2.
question?
Hello.
Wait. 1 second, one by one. Okay, I'll ask. So first tell me graded week 1. Any doubt there? Graded assignment.
No, ma'am.
Okay. Now tell me in week 2 practice assignment, is there a doubt?
Yes, ma'am.
Yes, ma'am.
2.1 question number 2.
Practice, not activity.
Yeah, I have also in doubt in practice.
Okay. Week 2 practice. Okay. Let's take that. Then we'll go to activity. 1 second. Yeah, which question, practice? Which two?
Question number
Ma'am,
7.
question,
7. Okay.
ma'am,
Okay, one by one we'll take. So question 7 is this one. Who asked this one, right?
Yes, ma'am.
Okay, see. It is saying that the following pseudocode is executed using scores dataset. What will count represent at the end of execution of the pseudocode? Okay. So scores dataset means which one? That dataset which contains data about students, right? Their marks, which city they are from, gender, all of these things. So now you go to the pseudocode. So first count is a variable which is assigned the value 0, initialized to 0. Now the while loop starts. So everything that is inside this while block, this curly braces, this will be repeated until this condition becomes false. Right? So table 1 has more rows. That is the thing. So while table 1 has more rows, you pick up the first row, that is pick up the first card from table 1. That is scores dataset. Table 1 is nothing but scores dataset. So now inside here, inside the while loop, we have initialized one more variable called c, which is assigned the value 0. Okay. Now when we initialize a variable inside a while loop, it means that every time we start a new iteration, this value will be reset to 0. Okay. So first c is 0, first iteration c is 0. If the person whose card we picked, if they have scored greater than 75 in maths, then you increment c by 1. So c becomes 1. If they have scored greater than 75 in physics also, then c becomes again incremented by 1. C becomes 2. If they have scored greater than 75 in chemistry also, again increment c by 1. So c becomes 3. Last if condition is checking, if c is less than equal to 2, then you increment count by 1. So when will c be less than equal to 2? Less than equal to 2 means it can take the value 0, 1 and 2. Right? C can take these values. So when is this true? One case can be when the person hasn't scored greater than 75 in any of the subjects. In that case, C will be 0 because no increment will happen. Correct? Then another case can be that that person has scored greater than 75 in any one of the subjects. Let's say in physics. Right? So C becomes 1. Another two can happen when the person has scored greater than 75 in two subjects. So at that time, C is incremented twice, so C will become 2. So these are the three possibilities in which case count will be incremented by 1. But if a person has scored
so ma'am,
greater than 75 in
so
all three,
sorry to interrupt you, ma'am, but here is C is not is count.
C and count are different variables.
Oh,
Count is initialized here. Count remains same.
so
But C will
C
be
is not
reset to
count.
0. No. C and count are different variables. No, that's why they're initialized differently.
Okay.
C is a separate variable, count is a separate variable. Count is initialized in the beginning, even before the while loop started. C is initialized inside the while loop. So every time we go for an iteration, C will be reset to 0. So let's say the first card that we pick, that person has scored 80 in math. Okay, just giving an example. First card that we pick, the person has scored 80 in math. Okay, 60 in physics. And let's say 50 in chemistry. C is initially 0. So is 80 greater than 75? Maths marks? Yes. So C becomes 1. C equals to C plus 1. 0 plus 1 is 1. Is 60 greater than 75? No. So no increment. Is 50 greater than 75? No. No increment. So C's value is what at this point? 1. Is 1 less than equal to 2? Yes. So increment count by 1. Now when I go to pick up the next card, see, move X to table 2. So this card's, whatever we wanted to do, we did. So move it to the other table, pick up the next card. As you pick up the next card, so read the first row from table 1.
Ma'am,
You
can you
again
solve this
reinitialize.
question with his course dataset?
That is very time consuming. You won't be asked to do that. What is it? The question is asking what? What will count represent?
So there is so many uh, card which has chemistry's marks is above 75 marks.
Yeah, there can be a lot of
So
combinations. But see what the question is asking you. We will obviously not ask you such a question where you have to go through all the cards in the data set.
I am
in exam.
sorry,
You
but
won't.
I am bit unclear on this point.
Madam,
Could
in
you
this
please
in this
explain it
condition,
more detail?
in this
Let me
condition, in
let
this
me explain this.
condition, yeah, continue.
First, read what the question itself is asking. It is asking what will count represent. It is not asking you for a value or anything. It's just asking what is count representing. We are not asking the value of count. So by looking at this code, so like I said, this is one iteration for this card. Now when I go for the next iteration, I pick up another card. Let's say that person has scored 80 in math, 75 in physics, and 78 in chemistry. This is one more person's card. So here, as soon as I pick up another card, C is again reset to 0. Again, I'll check all of these conditions and again update C accordingly. So at the end, count is getting incremented when? Count will be incremented when C is less than equal to 2. So what does that mean? Check the options now. Number of students who scored more than 75 marks in at least 2 subjects. Is this correct?
No.
Yes,
No.
yes, correct, madam. Yes, 2 subjects, no, okay.
It is saying at least.
At
That
least
means it can be 3 also. If I take 3, then 3 is not less than equal to 2.
present 2, yes.
So at least is the wrong word. It should be at most 2 subjects.
At most, yes.
Two subjects.
So
Yeah.
either he hasn't scored 75 marks in any subject, or in one subject, or in 2 subjects, not more than that. So option C should be your answer. Is this clear now?
Yes,
Yes, ma'am.
Look, we will not
Ma'am,
ask
can
you
you?
such question where you will have to count using the data set, because that is not possible in exam, right?
Yes, ma'am.
Yeah, what is the
Ma'am,
next question?
I have also doubt in third questions of practice assignment.
This one. This, right?
So we have two different
Ma'am,
variables.
only
Count
please explain only this. But okay, ma'am, you can continue. Sorry.
See. The given procedure finds the number of sentences with maximum number of words from the words dataset. So we want to find how many such sentences are there in the words dataset which have the maximum number of words in them. Right? It can be that let's say the maximum number of words in a certain in the entire words dataset in a particular sentence, the maximum number of words is let's say 10. That's the biggest sentence. Now there can be more than one such sentences. We want to find the number of such sentences which have the maximum number of words in them.
Ma'am, please
Okay, so
explain step 5. What step 5 is conveyed at?
all the steps
Read
I'll
the
go
top
through one
card.
by one. Okay. Just see. First is step 1 is arrange all cards in a single file. That is your words data set, all the cards. Now step 2 is initialize variables a, b and count to 0. So all 3 variables are initialized to 0. A is also 0 initially, b is also 0, count is also 0. Step 3 is the conditional statement. If pile 1 is empty, then stop the iteration. So this is the beginning of your while basically. If it is not empty, then read the top card. Add 1 to variable a. That means every time we are reading a card, we are adding 1 to variable a. Right? Step 6
Yes,
is
ma'am.
saying, if word does not end with a full stop, then go to step 11. That is, skip all of these steps. If it does not end with a full stop. When will a word end with a full stop? When it is at the end of a sentence. Right? So if I don't find such a word, which is like the card that I have currently picked, if that doesn't contain a word which is ending with a full stop, then I will ignore all these steps and go to step 11. That is, move the current card to a pile 2 and repeat from step 3. Pick the next card. So when will this step 6, after this step 6, when will I go to step 7? When I find such a card which has full stop along with the words, right?
Ma'am, can you please repeat?
Okay, look, I'll take an example. If this is your sentence, okay, this is the first card, this is second card, third card, fourth card. First card you
Yes.
picked I.
Mhm.
Okay, so read the top card. This is the first card you picked. Add 1 to A. So A was initially 0, now A becomes 1.
Okay.
If word does not end with a full stop, is I ending with a full stop? No. Go to step 11. So move this to another file. Go to the next card, am. So am, as soon as you read it, again you have to add 1 to variable A. So variable A now becomes 2. Right? Again, am does not end with a full stop. So move it to file 2. Go to third card.
Third
As
card,
soon as
yes.
you go to the third card, again add 1 to variable A. A becomes 3. But A doesn't end with this full stop again. Right? So you again go where? To step 11. So you again move this to pile 2. Go to the next card.
Yes, ma'am.
Now you again add 1 to variable A. Variable A becomes 4. Now this one ends with a full stop. So you will go to step 7. Step 7 is checking if A is less than B. Then go to step 10. A is 4 at this point. B is what? 0. So is 4 less than 0?
Yes. So we have
Is 4 less than 0? No. So now go to step 8. If A is greater than B, 4 is greater than 0. Correct? Then store A in B. So B becomes 4 now. And assign 1 to count and go to step 10. Okay. So assign 1 to count. So count, it is saying, has to be assigned 1. And go to step 10. That is reinitialize A to 0. Okay. So this is the part that we have to fill in, step 9.
yes, ma'am.
So let's understand what is happening so far. So this variable A, okay, this keeps track of what? Every word. When is it reinitialized? When we have reached the end of a sentence, right? Because
Yes.
this step 10 reinitialization will only occur if the word ends with a full stop, right?
Yes, ma'am.
So then we check that. First we check if A is less than B, then we check if it is greater than B. Then step 9, something should happen and then reinitialize. So let's see. So it is saying that as the procedure finds the number of sentences with a maximum number of words from the words dataset, there will be 3 variables required. So one variable to keep track of the number of sentences in just a second.
Madam, I have doubt in question the number of sentences with the maximum number of words. So if any one sentence only have the maximum number of words, right? So number of sentences means so it will be have more number of sentences. What is
Hello?
the limit? Hello,
Yeah.
hello.
See, this one is, I think, wrong. So it is one variable to keep track of the number of words in each sentence. It should be. And it should
So
be
this
initialized to 0. Okay, once a
eh,
sentence ends, it should be reinitialized to 0. Second variable is what? This first variable is A. A is keeping track of the number of words in a sentence. Second variable is to keep track of maximum number of words in a sentence. So that should also be initialized to 0. This variable is B. So this keeps track of maximum number of words. Okay, it should be updated whenever a sentence have more number of words than the current value. So let's say in one sentence that we pick, let's say the first sentence contains 4 words. Okay. So A was 4. We saw that B was initially 0. So this step 8, we checked that, okay, 4 is greater than 0. So assign that to B. So B is currently 4. Okay. Now the next sentence when we go to, if the next sentence contains 5 words. Okay. Then A will be what? A will be 5 because every time we count a word, A is incremented. Right. So now in for the next sentence, B is at this point 4 and A is 5. So again, B will be assigned 5 because A is greater than B. So B variable is storing what? The maximum number of words in any sentence that we have seen so far. And A is calculating the number of words present in every sentence. Okay, that's why this comparison is there between A and B. Now, let N be the number of words in the sentence which has the maximum number of words. So there might be more than one such sentence with N number of words. So to keep track of this, we need a third variable, which should be updated to 1 whenever the second variable gets updated, and should be incremented if any sentence has the number of words equal to the current value of the second variable. So this all is looking very complicated. Let's just take an example. So in step 2, 3 variables are used and initialized to 0. So what are the 3 variables? A, B, and count. Okay, A, B, and count. Now from step 5, it is clear that A is the first variable, which keeps track of number of words in a sentence. Like I said, I am a girl. 4 words, A is 4. Step 6, if sentence ends, that is ends with a full stop, then these 4 steps will be executed. Step 8, it is clear that B is the second variable and count is the third variable. So step 8 is being executed, then the iterator is moving to step 10. So that count does not get incremented for the same sentence. See. After step 8, we are directly going to step 10. Understood?
Yes, ma'am.
If step 7 is true, then also you go to step 10. If step 8 is true, then also you go to step 10. So when am I going to come to step 9? In step 8, whenever the new maximum value is being found, that is the current value of A is greater than B, and the length of the current sentence with respect to the number of words is being stored in B. That is, B now contains the length of the current sentence which has the higher number of words. At this point, count is assigned to 1. So if the next sentence has the same length, count should be incremented. Right? If we find 2 such sentences which have the same number of words in them, that is maximum number of words in them, then count is incremented. Therefore, step 9 should be what? If A equals to B, then add 1 to count. So first B should store what? Maximum length.
Yes.
Maximum length of a sentence. That should be stored in B. Okay. Now after
Yeah, ma'am.
that, we
I
should
got it, ma'am.
compare. Yeah.
Please forward to ma'am
compare with this.
8 number question.
Right. So this will be your step 9.
Yes, ma'am.
Ma'am, please repeat this step.
See, variable B should contain the maximum number of words in a sentence in the entire data set. Now, if any sentence length matches with that length, then we will increment count by 1. So that's why we are doing this comparison operator. A equals to B checks that whether some A contains the length of a sentence. If that length matches with the maximum length of a sentence, that is, we have found such a sentence which has maximum number of words, then you increment count by 1. Count should be storing the number of such sentences which have maximum number of words in them. Okay. So A and C are both correct. Actually, this is also correct. This is also correct.
Ma'am,
Yeah.
ma'am, I have having a little trouble with 8 number question that
Yes, 8 and
8 number, yes, 8 number.
this, right? Okay.
Yes, ma'am, yes,
So the
ma'am.
question is based on scores data set again. A, B, C are three variables, each containing 0. So this is initialized before the loop began, right?
Mm-hmm.
Once the loop began, we are going through each of the cards. Now, let's say the first person's card we picked is, just take a random card value. Okay, let's say the person scored 18 math, 19 physics, and 16 chemistry. So first, if condition is checking if maths marks is less than physics marks. So is it true in our case?
Ma'am, I have already understood this question. I have a trouble with these options that what is why second and third options are not correct.
Well, let me go through this question once. So if it is if maths is less than physics, then we increment all three variables. If maths is greater than physics, we only increment B and C, and if maths is equal to physics, we only increment C. Okay, it's simple enough. It is asking what will the value of C minus A represent? So
Yes,
C
ma'am.
minus A should represent number of students whose maths marks are at least as much as physics marks. Okay, see, if there are, so C will be incremented in all three cases, right? Whether maths
What,
is
ma'am?
greater than physics
And-
or C is incremented in all three cases. Whether maths
Yes,
marks is less than physics or greater than physics or equal to physics. But A is incremented in only one case when maths marks is less than physics,
yes, yes.
right? So if I do C minus A, then that should give me what? C is basically all students. And A is
I
those
think
students who have
I think
scored.
last two ifs are shows C's value.
C is going to be incremented in all cases. Okay, for every card. Only three possibilities are there. Either maths is less than physics or greater than physics or equal to physics. In all three cases,
But
C is being incremented.
there
That
A
means
is
if there
also
are
in
30,
there in this
yeah,
if loop.
C. First, let's deal with C. If there are 30 people, so for each one of them, any of these conditions has to be true, right? Any one of them have to be true for these 30 people.
Yes.
So C's value at the end will be 30, regardless of whatever the condition is. Because in any case, C is getting incremented. But A is getting incremented only when the maths marks is less than physics marks. So let's say there are 10 such people who have scored maths marks less than physics marks. So in that case, A becomes 10. So what is this C minus A? That is this 20 is representing what? Number of people who have scored at least as much in maths as in physics or greater.
And what about ma'am other C's?
What other C?
Just in second if loop and third if loop.
These are all the same variables only. This ABC
Ma'am, but there is
variable,
a
there are only three variables. So in
but
any
ma'am
case,
there are
either
so
this
many
if will be
conditions, no?
true. Understand this. Either this if will be true, or this if will be true, or this if will be true. In any of the cards, is it possible for more than one if condition to be true for a particular student? Can a student
No,
simultaneously score less than maths in physics and greater than maths in physics? Not possible. Either this condition will be true, or this will be true, or this will be true. Based on that, you will do the increments.
not all.
No, all is not possible. No? If I score
Okay.
18 maths and 19 physics, any one of these conditions I can say that evaluates to true. So greater in physics than maths. That means this condition is true for this card. Are these two conditions true? No. If I have scored
Because there
18
is no
maths and
A.
19 physics, A,
Okay,
see,
ma'am.
the increment part depends on the if condition. Whichever condition is true, you will do only that increment. If maths marks is less than physics marks, then you increment all three. If maths is greater than physics marks, then you increment B and C. If both are equal, you increment only C. So C will be incremented regardless. C will be incremented for all students. But A is incremented only in one case. That is when maths marks is less than physics marks. So if I do C minus A, I will get those students who have scored at least as much in physics as in maths.
Yeah. Please explain, ma'am, option.
Yeah, option A is saying that number of students whose maths marks are at least as much as physics marks. This is correct. And D is also correct, that number of students whose physics marks are at most as much as mathematics marks. At most, why? If it is greater, at most means what? If a person has
Maximum.
scored, yeah, at most as much as maths marks. So if a person has scored, let's say 70 in physics and 80 in math. So which of these if conditions will be true?
Second.
Second one, right? So this is one that I can take. And if they have both, if he has scored 70 in both, then which condition
Third.
is true? Third one.
Third.
But in any of these two cases, is A getting incremented?
No.
A is getting incremented when physics is greater than maths.
Yeah.
Right. So if I take out A from C, then only those people are left who are evaluating these two conditions. That is, physics marks is at most as much as maths marks. It cannot be greater than maths marks. Then A will be incremented.
Okay, ma'am. Ma'am, I have a question for from this question that in exam if we see this type of this type of questions, they are in which too much if condition. So we are following only if condition, only one if condition.
Look, if condition means that if there are 2, 3 such if conditions given one by one, so you have to
Mm.
check all the ifs and whichever is evaluating to true. Okay. For that, you have to perform whatever is in the curly braces. So in such questions here, like you don't have a data set. So you have to understand using the question itself that what does A, B and C represent? Here, this is the main question. What is A, B and C representing? So you tell me,
Okay.
after I have gone through the entire data set, all 30 cards, A will represent what actually? What is A variable representing? Just try to answer this.
A represent mathematics marks is greater than physics marks.
A represents number of people who have scored less in mathematics than in physics. Because A is getting incremented when? Only when this condition is true, maths less than physics. So for those people, A will be incremented who have scored less in maths than in physics. So if there are 5 such people, A will be 5.
Yeah,
Understood?
math is less than, yes.
Similarly, if there are 10 such people who have scored greater in maths than in physics, then B and C both will be incremented. In fact, in case of this condition, in case of this if, all A, B and C are incremented in this question. So if there are 5 such people, then A, B, C all are 5. If there are 10 such people who have scored greater in maths than in physics, then B and C are incremented. Okay, but they're not exclusive of each other. These are the same variables. Okay, depending on which if condition is true for your current card, you will just execute that if. So you just have to understand what is A, B, and C representing. So A represents number of students who have scored less in maths than physics. Okay.
Yes, ma'am.
B represents what?
Also, mathematics
Number of
less than
students.
physics.
Basically,
Number
B
of student
represents number of
mathematics.
students who haven't scored same marks in maths and physics. Number of students whose maths marks is not equal to physics marks. It can be greater, it can be less. See, in both cases, B is incremented. Right? And C represents what? C
Ma'am,
represents all students.
why you B not no, there is no, ma'am, why you write mathematics is equal to physics in B?
No, it is not equal to. This is not equal to sign. Exclamation equal to means not equal to. Okay, so in this type of question, you have to find out what each variable represents. All right. Any other doubts?
No, ma'am. Thank you.
Anyone else?
Ma'am, could you explain activity 2.6, question number 1?
Okay, activities. 1 second, let me open that.
We can ask also activity question.
Yeah, let me answer some since we have some time. Just wait 1 second. Okay, I'll take up the questions from the first few activities. Rest you can do in tomorrow's class because tomorrow also it is week 2 only and we don't have much left to do. Okay. Is my screen visible? I don't think so.
Ma'am, tomorrow is also session.
Yeah, tomorrow is also week 2 session only. That's why I was not going to take activity questions, but let's do 1 or 2. Okay. Which question? 2.1?
Question 1.
Question number 2.
Okay, this question, does anyone have a doubt in this first question? First question, anyone? Okay, this second one? Yes, Aniket, you want to say something?
Yeah, but not related to this section. I have a general doubt.
Yeah, you can ask.
The doubt is I am not able to submit assignment 1. Then how it will affect my uh, grading system?
Just go through the grading document once because some things have been revised. So I don't know what is the current deal. But as far as I know that the top 7 assignment scores are probably taken for evaluation. So yeah, but just check the grading document once and there it is given.
Okay, thank you.
Yeah, okay. You told me to solve the activity questions. Tell me which ones you have problem in.
I think, ma'am,
Question number
you
1
gonna
and
ask
2.
1 and 2.
2.1,
2.6.
2.6. Okay.
Yes.
2.6, which one?
The first one.
Okay. This is saying that without modifying any step in the given lecture, in the procedure in the given lecture, is it possible to find the word that has maximum frequency? I don't know what procedure is in this particular lecture.
I know, ma'am. Can I explain?
You just tell me which procedure is there, max in a single iteration.
Hello?
This is the max in a single iteration procedure.
Ma'am, there is no word which has shows which word has maximum frequency in lecture.
Yeah,
So
but
how
in
we
this
could?
case, I think this is if it is that one. So this type of question is based on the lecture, no? So this lecture I think is finding max in a single iteration. So you have to go through all of the words to find the maximum frequency, I
Yes.
think.
Yes,
Yeah,
ma'am, you're right.
it's just based on the lecture. So this type of question is okay for activity. It won't come in your any of your exams because this is not possible. You won't have a data set. Okay, any other question? Activity? Any activity?
Ma'am, in 2.4, question number 2,
0.4.
Why 60 is not answer? Mm, why
Let me check.
30? And please also explain the feedback also.
This all these questions, right?
No, ma'am. Question number 2.
Okay, and what is feedback?
Please click on check answer. Yeah.
Okay. Yeah, see this question, I'll tell you. Okay, question 2 is saying assume that we have already figured out the maximum number of bills generated by any shop. So this is from shopping bills dataset. It is stored in a variable called max. Okay, this is maximum number of bills generated by any shop. Stored in variable max. Now we have a new pile containing 30 cards. All cards in this pile are bills from 3 new shops. Okay, so we have 3 shops in our dataset, right? SV Stores, Big Bazaar, and Sun General, something like that. And now we have a new pile containing 30 cards, and all these are from 3 new shops. So what is the least number of cards that we have to iterate over to determine the maximum number of bills generated among all 6 shops? Okay. So note that the dataset already has 30 cards. So it is saying that assume there are 2 decks of cards, each have 30 cards. So one deck is our normal shopping bills dataset. Okay. That has 30 cards.
Yes, ma'am.
And another deck is this new deck, which has cards from bills from 3 other shops, right? That also has 30 cards. So every deck belongs to 3 shops. Now pick the first deck and the maximum bill generated by any shops among 3 shops. Let's say in the first deck, Big Bazaar has the maximum number of bills. Let's say 15, maybe. Okay. So the procedure for this will be what? We have to maintain 3 variables corresponding to 3 shops, and every time we get a bill, we check the name of the shop and we increment the corresponding variable by 1, right? And then at the end, I will compare all 3 variables and store the highest value in max set. Okay, this store has generated the maximum number of bills. So we have to do this for both the decks. Okay, now take the second deck and try to do the same, but this time we are not finding the maximum bill generated by 3 shops. Okay. Oh, all right. So they are saying that first we will do this with the regular deck that we have. Okay. Regular deck, first we will find out which shop is having the maximum number of bills. Now take the second deck, that is the new deck, which has cards from three new shops. But this time we are not finding maximum bill generated by 3 shops. Now we are trying to find maximum number of bills generated for either 6 shops. That is all 6 shops among 2 decks. So there are many ways to do, but until you pick the 30 cards and find which shops generated the maximum bill, right, the best way to do this is again you maintain 3 variables for 3 new shops, find the maximum, store it in another variable max1. Now you compare max with max1, and whichever has the higher is greater. So basically, see, what you have to do is first deck has 3 shops, right? Let's say S1, S2, S3. So for these 3 shops, we will find out which one has generated the maximum number of bills in the first deck. Okay. Let's say S1 has generated 15 bills, that is the max. Now for second deck also we have, let's say, 3 more shops, S4, S5, S6. Here also we have to find out which shop has generated maximum number of bills. Let's say S4 has. So this S4, let's say, has generated 16 bills. So now max contains 15, max 1 contains 16. So you compare max and max 1. Okay, that will give you this. So you need to iterate over at least 30 cards.
Ma'am, but we have total 60 cards that we are going to iterate and find maximum number of cards, maximum number of frequency. So maximum number of bills, sorry. So
So
why this?
it is saying that what is the least number of cards that we have to iterate over to determine the maximum number of bills generated among all 6 shops. So you can consider that the first deck iteration is already done. Okay.
Okay.
So you are just checking for the new deck which has 30 cards. So from this
So
new
ma'am,
deck, if
we
you have
have
to
3
compare.
shops in first deck, and second deck we have 30 cards. Sorry, 6, 3 more shops. So there is
Yes.
here they ask 6 shops,
But
not
when
3
we
shops.
no. See, the question is saying that you have to do comparison between 6 shops, right? So the first deck has 3 shops, the second deck has 3 shops. Okay.
Hmm.
Now when you do the comparisons in the first deck to find the max, then you are comparing among how many shops? 3 shops only. Right? First deck,
Okay,
H1,
ma'am.
H2, H3. But when you go to the second deck, then you are comparing among 6 shops. So only the second deck 30 cards will be counted.
Okay, ma'am. I got it.
Okay. Any other activity question?
Yes, ma'am. 2.7.
2.7. Which one?
Ma'am, in third questions and third and fourth.
Okay, third is based on the first two. So max marks is a variable that keeps track of maximum total marks in scores data set. Max card is a variable that tracks the index of the card which has maximum total marks. So we write a procedure similar to the one given in the lecture to determine maximum total marks and index of the card corresponding to it. Okay. If max marks is updated n times during the execution, how many times is the variable max card updated? So if max marks is updated n times, max card also has to be updated n times. This is saying let there be n cards in the pile. Assume that the pile is arranged in ascending order of total marks, so that the total marks in any given card is always less than the total marks in the card immediately below it. Assume that no two cards have the same total marks. So how many times the variable max card will be updated? Again, n. If there are n cards all having different total marks, so n times it has to be updated. Now, based on the answers from the above questions, what is the correct relationship between small n and capital N? Small n is what? How many times max marks is being updated, right? And capital N is number of cards. Okay. So
Yes, ma'am.
number of cards, it cannot be greater than, number of comparisons. Okay. How many times it is getting updated? That cannot be greater than the number of cards itself, right? If I have 30 cards, I cannot be updating 31 times. That is not possible. At max, you might have to update 30 times. So n, small n, that is number of times we are
Small
updating.
n. Okay.
Small n is number of times you are updating. Okay. To find this maximum total marks. And capital N is the number of cards. So number of updates can never be greater than number of cards, right? It can be at most
Yes, ma'am.
the number of cards itself. So it has to be less than equal to n. Capital N.
Okay, ma'am. I got it. Fourth question.
Yeah, this is a pseudocode. Arrange all cards in single pile, pile 1. Maintain two variables, count and previous. Initialize them to 0 and none. Read and move one card at a time from pile 1 to pile 2. If word is equal to was and prev is equal to it, increment count. Store word in prev. Okay. And repeat steps 3 to 5 until pile 1 is empty. So initially two variables are there where count is 0 and previous variable is initialized to none. Right, now every time we pick a card, we are going to check in step 4 the condition that if the word is equal to was. Okay. If the word is was and previous is equal to it, that is previous variable is containing the word it, then increment count and store the word. Step 5 is store the word in prev. Okay. So when will previous be updated?
Yes, ma'am.
Yes,
I was understood. Yes, ma'am. So much.
it is just going to calculate the number of times.
Yes. I got it, ma'am. Thank you.
Yeah. Okay, so if you have other activity questions, just ask in tomorrow's session because I'll tell Piyush sir that no, nothing else is left from week 2. So you have covered the theory part and also practice and activity, some doubts also. So any other doubts in activity or practice, you can ask tomorrow's session. Okay, that will be on week 2. Next, we will start week 3 from Monday. Okay. All right. Thanks for joining, everyone.
Okay, ma'am. Have a nice day, ma'am. Thank you.
Okay, ma'am. Thank you, ma'am. Thank you.
Yeah. Is anyone
Thank you,
asking
ma'am.
something?
Thank you.
Thank you, ma'am.
Yes, ma'am. Actually, I'm having doubts in week one practice assignment. If you could just give 5 minutes.
Okay, week 1 practice, right? Which question?
The first one.
Okay, let me share. This one. Oh, wait. This question.
Yes, ma'am. Ma'am,
Yeah,
in
what's the
this,
doubt?
getting confused with the ABC variable because how do you take the range of the months?
See, anyone who is born before 1st May, that is everyone that is born up to 30th April, right? All of those people come under A variable. Okay, and whoever is born after 30th April and before 1st September will come under B. And anyone who is born after 31st August will come under C.
So, ma'am, like after 31st, greater than 31st August, like from August, then September, it goes till July then.
Greater than 31st August means what? It starts from 1st September, right?
Yes.
What is the next date after 31st August? 1st September. So from 1st September to what?
Till
See, anything less
till the
than
next year.
1st May. Okay, anything. Let's first do the this thing distinction. First, A is having anything less than 1st May. Okay, less than 1st May means start from January. January 1st to
Yes.
April 30. Everything comes under A. Okay, now 1st May to 31st August. Everything comes under B. And from 1st September to 31st December, everything comes under C. Okay,
Okay, ma'am, yes, got it.
all right.
So, ma'am, we consider it till the next year, right? We do not continue it
No. Just
till
consider it
the
till
current year.
December. Yeah,
Okay, yes, ma'am. Thank you.
yeah. Okay, thanks.
Thank you, ma'am.
Yeah, thank you. Please join tomorrow's session, okay?
Thank you, ma'am.
Thank you, ma'am.
Good day, ma'am.